Good morning, good morning, good morning. I hope everyone is happy and healthy and doing absolutely fabulous on this January day. So, continuing with our Properties of Exponents lessons, we are going to be looking at the powers or properties, all of the properties of exponents. I want to make sure we have some common vocabulary in place. So, we have a number. It would help if I actually... Okay, let's try this again. If we've got 3x to the fourth, I want to make sure we know 3 is not the base, it is the coefficient. X is the base, and 4 is the exponent. If I were to add parentheses into this, so I put 3x to the fourth with parentheses around the 3 and the x, no longer is 3 the coefficient for the power. Instead, it is simply the coefficient for the term, and now the base is actually 3x with an exponent of 4. And that's going to be important when we look closer to these rules for exponents. I like to teach this kind of doing a modification of PEMDAS and use mad spasm. When we multiply coefficients, we're going to add the exponents. When we divide the coefficients, we subtract the exponents, and we take a power to a power, we multiply the exponents. That's what basically these rules say. So when we multiply, and notice how these both have the same base. So it's important to recognize that we're looking at numbers that have the same base. So because we have the same base, the base stays the same, and all we've done, because we're multiplying, we're going to add our exponents. When we're doing the power of a power, so product, we're going to raising a power to a power, you're going to be multiplying the exponents. Now what's different about these two is that m is an exponent in our term. Here, A and B are two different terms with the same term with two different bases. So in this case, we can distribute basically the exponent to both of the terms. If it's a negative, it means we're simply going to put 1 over and change the exponent from negative to positive. Quotient means we're subtracting. So you can see we're going to do m minus n. And again, just like with the product of powers, the base is the same. And very similar to the power of a product, power of a quotient, you can see all we've done is basically distribute the exponent to both the top and the bottom. Okay. So let's see how we're going to do these. So again, we multiply our coefficients. We see multiplication, so we're going to multiply the coefficients, which that means the only number I see there is 4. The base stays the same. And since we're multiplying our coefficients, we are going to add our exponents. So we have 5/3 plus 3/2. Well, if you don't feel comfortable doing that, that's okay. Use your Desmos or scientific calculator. And if we do 5/3 plus 3/2, and then you use it as a fraction, we're going to leave it as 19 over 6. Now, if you do the long version, what you're basically doing is I have to have the same denominator, so I'm going to multiply both the top and the bottom by 2. I'm going to multiply the top and the bottom by 3. That gives me 10 over 6 plus 9 over 6. Tic-tac-toe, 3 denominators in a row. 10 plus 9 is 19. Hence our 19/6. And this is our final answer. Here, because we are raising the power to a power, we are actually going to multiply. So we are going to be applying this rule. So we're going to multiply our two fractions. 3 over 4 times 2 over 3. Those cross cancel, these cross cancel. So we are left with 1/2. So this is y to the 1/2 times x to the 5/3. Now the next question is, can I combine those? Well, are the bases the same? No. The base on this one is y, and the base on the other one is x. And so because the bases are not the same, we are done. Okay. So we are multiplying, and when we multiply, we add. So we've got 3/2 plus 1/2. That gives me 4/2, which is the same thing as 2 over 1, which is 2. So I have a squared over a. Now, I know that that's the same thing as a to the first power. So now I have a division problem, and I simply am going to subtract. So 2 minus 1 is 1. Another way to look at this, if I were to expand this into, so a squared is the same thing as a times a, and a to the 1 at the bottom. If I cross cancel, we are left with just a single a at the top. Okay, and this one means we are going to distribute the power to both the top and the bottom. And because I'm raising a power to a power, I'm going to multiply. So the first thing I know I'm going to do is 3/2 times 2 over 1. Cross cancel. I'm left with 3 over 1. So this becomes m to the 3rd over m squared. And then that leaves us with m times m times m over m times m. Our final answer is m to the first power. It says simplify each radical. Ooh, how does that mean? All right, what we're doing is we're basically going to come up with numbers that we can multiply times itself to go into 112. So I'm going to actually think about in terms of to the 4th power. So I know that 2 to the 4th power is 16. So I'm going to see if 16 is a factor for 112. So I'm going to take 112 and I'm going to divide it by 16. And sure enough, 16 times 7 is 112. That means I have the 4th root of 16 times the 4th root of 7. And I know what the 4th root of 16 is. That is 2. So I have 2 times the 4th root of 7. And that's simplified. So again, I'm going to be looking for numbers that can come out of these. So I'm going to think about numbers that are cube roots. So I know that 2 cubed is 8, and 8 is not a factor of 81. 3 cubed is 27. So let me see. So I get out my calculator and I'm going to divide 81 divided by 27. And sure enough, it is 27 times 3. Well, that means I can break it up into the cube root of 27 times the cube root of 3. And I know what the cube root of 27 breaks down to. That is 3. Oh, I forgot my 8 out front. So we're going to have 8 times, this is now going to be replaced with 3, times the cube root of 3. 8 times 3 is 24, cube root of 3. And there's our final answer. So again, we're going to be looking for numbers that we can factor out. So 2 to the 5th power is 32. So I'm going to look and see, does 96 divide evenly by 32? And sure enough, I got lucky again. So 96 is going to be 32 times 3, and then we have u to the 5th and v to the 3rd. Now, remember from yesterday's lesson that the exponent goes on top and the radical goes on the bottom. If I do this, can I simplify 5 divided by 5? I certainly can. That's 1. Oh, okay. So I know that the 5th root of 32, I have the 5th root of 3, I know the 5th root of u to the 5th. Do I know the 5th root of v to the 3rd? Well, does 3 over 5 simplify? Nope, it's a decimal still, so I'm going to leave it inside. Okay, so the 5th root of 32 is 2, and the 5th root of u to the 5th is u, and then I leave my 5th root the same for everything else, so 3v to the 3rd. And to the 4th root, so 2 to the 4th, again, is 16. And let's see if 80 is divisible by 16. It is. So this separates into the 4th root of 16 times 5. And let's put our fractions on top of one another. So we've got 6 over 4. I can reduce that. I can take one of my 4's out of there. When I take a 4 out, what am I going to be left with? Oh, 2. So I can separate my x to the 6th into 2 groups, x to the 4th and x squared. And my y to the 8th can split into y to the 4th and y to the 4th. And I can take out 2 of those. So technically, I'll be taking out y squared. Got it. Okay. So I break up my 4th root of 16. I know that is 2. I'm going to bring an x out, and I'm going to bring 2 y's out. What stays on the inside is my 5, and then I still have my x squared hanging out inside. Okay, properties of radicals. So the base stays the same, and then I add or subtract the exponents. So the base here is the cube root of 6. So basically I have a -1 minus 1. Sorry, -2 minus 1, which gives me a -3, and then drop on our cube root of 6. Is our base the same? No. So we need to make this base the same. So we have 3 cube root of 32. So 32 can be broken up into 8 times 4. And I know that 8 is a cube root because 2 times 2 times 2 is 8. That means 2 is going to come out. So this becomes 3 times 2, and then cube root to the 4th. And 3 times 2 is 6, so it's 6 cube root of 4. So we have -3 cube root of 4 plus 6 cube root of 4. Now I can see that my bases are the same. And so now I just have -3 plus 6 is a +3, so it's 3 cube root of 4. When we're multiplying, you can actually multiply what's going when the root on the outside is the same. So when the radical is the same, I can multiply those two numbers and put them underneath my cube root. So 4 times 16 is 64. And then I can simplify this further to see if there's anything that goes into the cube root of 64. Well, 2 cubed is 8. And 8 times 8 is 64. So I can change this to the cube root of 8 times 8. And I know that the cube root of 8 is 2. So this is going to be 2 times 2, which is equal to 4. So my bases are not the same, but my fourth roots are the same. So I can multiply 3 times 5 and get 15. And I can multiply what's inside the radicals. So I've got the fourth root of 24 times 2, which is 48. Now let's see if I can substitute or simplify the fourth root. So to the fourth power, 2 to the fourth power is 16. Is 16 a factor for 48? Yes, it is. So this becomes 15. The fourth root of 16 times 3. The fourth root of 16 is 2. So 2 comes out. So 15 times 2 times the fourth root of 3. And what's 15 times 2? 15 times 2 is 30.